Welcome friends. So in the last lecture we have seen the ABCD parameter evaluation of medium transmission line for both T network model and pi network model. Now in this lecture we shall briefly demonstrate how different parameters are calculated for a medium transmission line. Let us say we have a transmission line. Let us say we have a transmission line 250 kilometer long. We have sending end voltage as Vs. We have receiving end voltage is always maintained at 132 kV. We have load which is equal to 25 MVA at 0.8 power factor lagging. The line data are given. Resistance value is equal to 0.11 ohm per kilometer. Inductance value is given 1.24 millihenry per kilometer and capacitance value are given 0.0094 microfarad per kilometer. Now you need to evaluate two parameters. Number one, sending end voltage, and secondly, voltage regulation. So we have, that well-known equation, that is Vs is equal to A VR plus V BIR. Now in just previous lecture, in pi representation, we found that A is equal to 1 plus yz by 2 A is equal to 1 plus yz by 2 and B is equal to z. So we shall see, or we shall use these two formulas to evaluate Vs. This is number one. Number two, what is the regulation formula? It is actually the percentage regulation is equal to no load voltage minus full load voltage by full load voltage into 100%. Now in medium transmission line, VFL is equal to VR is all right. VFL is equal to VR, that is all right. Full load. Now what will be no load voltage? What will be no load voltage? This is problematic because in short transmission line, it is equal to Vs because there is no shunt path in case of short transmission line. Okay. So in case of medium transmission line, what will be V no load? So from the equation, you can say that Vs is equal to AVR plus BIR. That means no load means IR is equal to 0. So putting IR that is equal to 0, we have VR that will be is equal to Vs by A. So in medium transmission line or long transmission line, no load voltage is equal to Vs by A. This is basically no load voltage for medium transmission line and long transmission line. So in percentage regulation formula, we shall use V no load as Vs by A minus VR by VR. So now let me start solving. So let me first quickly evaluate what is the full value of resistance. So resistance value is 0.11 ohm. So total resistance is 0.11 into 250 kilometer because the length is 250 kilometer long. So this value is found to be I think 27.5 ohm. 27.5 ohm. Now inductance value is what? It is L is given, so XL, that is total XL. So total resistance we found, total resistance we found 0.11 ohm per kilometer, that multiplied with 250, that is equal to 27.5. Total reactance, total reactance. So again it will be 314 into L. L is 1.24 millihenry, 1.24 millihenry. So it is Henry per kilometer into 250 into 250, and that will be coming out to be, that is coming out to be 97.34 ohm. So now with these two we can have total impedance. We can have total impedance value Z, that is equal to 27.5 plus J 97.34 ohm, and that is equals to 101.2 at an angle 74.2 degree. This is the total impedance. Now total admittance. What will be the total admittance? Total admittance Y is equal to J omega C, and that multiplied by L, that is the length of the line. So J 314 into C. C is how much? 0.0094 microfarad per kilometer. So that we can write 0.0094 microfarad per kilometer. So it is 10 to the power minus 6, and that multiplied with 250, and it will be coming out to be 7.38 into 10 to the power minus 4 angle 90 degree mho. This is the total impedance value, and this is the total admittance value. Now what we have with us? What we have with us? We have VR. We have VR, that is equal to 132 kV. 132 kV. We have VR is equal to 132 kV. This is line voltage. Okay. So we have VR phase. We have VR phase, that is equal to 132 kV by root 3, which is equal to 76.2, I think. Yeah, 76.2 kV. It is phase. Power, receiving end power, it is given 25 MVA at 0.8 PF lagging. So from these two data we can evaluate IR. We can evaluate IR. So it is 25 MVA, that means 25 into 10 to the power 6 by root 3 into 132. That is equals to 109.34 at an angle of minus 36.9 degree. So we have got VR, we have got IR. So from these two we can calculate VS. We can calculate VS. So what is VS? VS is equal to AVR plus BIR. So now what is A? A is equal to 1 plus YZ by 2. Let me evaluate that. So it is equal to 1 plus, now what is Y? Y is equal to 7.38 into 10 to the power minus 4 angle 90 degree, that multiplied with 1.2 at an angle of 74.2 degree. So if you solve this, you will get A is equal to 0.9542. Your A is this. So we can directly write what is VS. VS is equal to AVR, that means 0.9542 into 76.2 kV plus IR into Z. So what is IR? 109.34 angle minus 36.9, that into B. What is B? B is equal to Z. So what is Z? Z is equal to 101.2 angle 74.2 degree. So this minus 36.9 is coming due to power factor is 0.8. This is due to the fact. So now if you solve this, you will get, this is 72.71 plus this is 72.71, and this term will coming out to be 11.1 at an angle 37.3 degree. This expression. So if you solve this, ultimately this will come 81.8 angle 4.7 degree kV. So this is your VS phase to phase. So now what is VS line voltage? So it is 81.8, that multiplied by √3, which is equals to 141.7 kV. 141.7 kV. It should be kV, not kilowatt. And this angle 4.7 degree, it is called load angle delta. This 4.7 degree is called load angle. Now what is percentage regulation? Percentage regulation is equal to VNL minus VFL by VFL into 100%. So VNL, as you know, VS, it is VS by A. So VS is equal to 81.8. That should be divided with 0.9542, which is equal to A. minus VFL, that is full load voltage, that means VR, that is 76.2, and divided by 76.2 into 100%, which is coming out to be 12.5%. So percentage regulation is 12.5%. So with this we have solved one problem on medium transmission line. We have considered the pi representation of the model. It can also be solved using T representation model. I am expecting that you solve that same problem using T representation model and tally both the results, whether they are same or different. Okay, with this I am ending my lecture here. In the next lecture we shall start the analysis part of the long transmission line. Thank you.